Subtopic number 4, which is on power and power factor. So in this subtopic, you have to be able to apply it alternating current circuit consisting of RRC, RL, and RCL in series. Okay, so the formulas are different, so make sure you know which one to use lah. Okay. So, average power is also known as real power. There are no power dissipated in capacitor and inductor. Okay, so the capacitor and inductor, instead of dissipation, they absorb the power on the first quarter. Lepas tu, they return to the alternating current punya generator on the next quarter cycle lah. Okay, so the on the power dissipation takes place in resistor sahaja. Okay, so that's why sekarang kita cuma consider the voltage across the resistor ataupun R lah. Okay, so I and V ni walaupun dia tulis RMS, kamu ingat this is RMS punya value lah. Okay, so from the phasor diagram, we know that cos V is equal to VR over V. This is the adjacent time dengan the hypotenuse lah, itu bermaksud dia tu. Okay, so kamu tahu VR is gonna be equal to V cos V. So when we substitute that into this equation, we get this equation here. Okay, so we get lah satu equation yang macam ni. Okay, so V is also equal to VRMS is also equal to IRMS times dengan the impedance. So we can actually let it equal to this equation as well. Alright, so cos V is the power factor lah. Okay, and this is the average real power. This is the apparent power. Okay, now let's look at power factor. Power factor is cos V. It can be calculated using this equation here. Ataupun yalah itu je pun. Ataupun this one betul tadi. Okay, so the apparent power pula dia akan equal to I square Z ataupun IV. Okay, RMS lah RMS. So from the phasor diagram, power factor can also be calculated using this equation here. So kalau kamu kena bagi these two saja, kamu directly dapatlah power factor. Okay. Lepas tu we have instantaneous power, which is defined as the product of the instantaneous current and voltage. So ini adalah instantaneous power for each of this lah. Okay. So kalau kamu tengok the pure capacitor and pure inductor have the same formula. Okay. Right. And this is basically a summary for the instantaneous power and average power for resistor, capacitor, and inductor. Okay, so let's look at example number 6. So we have this is as capacitor, this is inductor, this is resistor. Okay, so this is the equation given. We have to calculate the frequency. So the frequency of the source, we can use omega. So this is 100 pi radian per second. So this is F is equal to omega over 2 pi. Harap kamu tidak confuse dari mana lagi ni equation, tapi dia dari sini. Okay, so from here it's gonna be 100 divided by 2 pi, which give you 15.9 hertz. Right? Question B pula, the capacitive reactance and inductive reactance, that is just XC 1 over omega C. Kenapa kita guna omega? Sebab omega sudah kena bagi dalam soalan. So senang sikit lah kita mau kira. So that is 100, C is 100 micro. So kamu akan dapat 100 ohm as the capacitive reactance. XL pula, it's just 2 pi FL. So 2 pi F is 2 pi FL omega L lah basically. So this is 100, and then L is given as berapa tu L tadi? 4 Henry. So this is equal to 400 ohm. Okay, so kita sudah dapat inductive and capacitive reactance. Lepas tu dia minta apa? Dia minta impedance of the circuit. So impedance is Z. This is an RCL circuit. So this is how you calculate the impedance. Okay, so from here you will get 302 ohm. Yang tu kamu substitute je, kamu make sure tulis. So question D pula, we have to calculate the peak current in the circuit. So peak current we can use V0, I0, Z. Okay, so I0 is basically V0 over Z. So Z pun kita sudah ada, V0 pun kita sudah ada. So just substitute lah. Kamu akan dapat the peak current to be equal to 1.72 ampere. Right? Okay, lepas tu dia minta the phase angle. So the phase angle is just phi. So how do we calculate phi? We are gonna use shift tangent XL minus XC divided by R. Okay, so yang ini 400 tolak 100 divide by 35. You will get the phase angle to be equal to 83.3 degree. Okay, lastly, the power factor of the circuit, that is just cos phi. Okay, so cos phi is just cos 83.3 degree, which will then give you 0.117 as the power factor. Okay, so you can either write as PF ataupun power, tulis full lah power factor. I'm not sure if the examiner understand PF, but I guess it's safer to write as power factor instead of PF. Okay, right, the final example in this chapter is example 7. We have a 22.5 millihenry inductor, and then this is resistor, this is capacitor connected in series to the alternating source of 240 volt 50 hertz. So this is F, this is RMS. So we have to sketch the phasor diagram for the circuit, but before we do that, we need to know whether the inductor ataupun capacitor yang bigger. So how do we do that? We are going to calculate XL and XC lah. So this is 2 pi FL. This will give you 7.07 Henry, and then we have XC, which is 1 over 2 pi FC, which is equal to 98.5 ohm. Oh, sorry, this is supposed to be ohm. Okay, right, so kita sudah dapat ni. So based on this, we know that XC is greater than XL. So our phasor diagram will be more downwards, ataupun our circuit is capacitive, gitulah. Okay, so this is Z, this is VC. No, sorry, not VC. We write XC. XR, this is R. This is XL, this is V. And then this is current. Okay, so that is your phasor diagram. Next, we have to calculate the power factor for the circuit. So for the power factor, we are going to use we are gonna find phi dulu lah. Okay, I'm just trying to remember if there's any easier ways to calculate power factor. What do we have just now? We do have R. Do we have Z? Did we calculate Z? I'm not sure. Z. I mean, we could, right? Okay, let's just do that. So power factor is equal to for this case, actually gonna use cos phi, and this is R over Z. So we just have to find Z lah. So Z is R square plus XL minus XC square. So from here, the power factor will be equal to 0.754. Supposedly lah. Just let me double check that. So R is 105 plus XL minus XC, so that is 7.07 minus 98.5. Square root this, so your Z is supposed to be 139 ohm, and then R is 105 divided by this, we will get 0.754. Yes, so that is the power factor lah. Okay, next we have to determine the average power consumed by the circuit. So the average power, we know that we are gonna use IRMS, VRMS, cos phi. Okay, so from this case here, what do we have? We do not have the IRMS value. So if we substitute VRMS over Z, VRMS cos phi. Okay, dari mana yang saya dapat yang ni? This is VRMS, V equal to IZ. Macam tu lah. Okay, tapi ni ingat this is RMS. This is for the source. Kalau dia untuk capacitor, dia akan jadi XC. Kalau dia untuk inductor, dia akan jadi XL. Okay, ingat yang tu lah. Right, so kamu akan dapat the average power to be equal to 312 watt. Okay, right, so that is the solution for example number 7, and that is all for chapter 6.